Well, good afternoon. My name is Alyssa Miller. I'm the CEO of iMiller Public Relations, and I am thrilled to be a host moderating this conversation with Nabeel Mahmood, who is a strategic advisor to ZincFive, and he is joined by Brandon Smith, the Vice President of Global Sales and Product for ZincFive. In our conversation, we are going to talk about why AI still needs people. So when we talk about scaling AI, why do you believe people, not power or compute, are the true limiting factor?
Well, Alyssa, for starters, thank you very much for having us. This is absolutely amazing and lovely to actually be spending some time over here with Brandon as well. So, to answer your question, I reckon the hardest part of scaling artificial intelligence isn't just plugging more servers into a rack. It's about having people who know how to design, run, govern these systems responsibly. Compute is becoming abundant, and skilled practitioners are not. If you don't have people who understand data plumbing, model behaviors, and operational risks, we are going to end up with a lot of horsepower and no drivers. So just imagine, driving a Formula One and, Brandon has got plenty of Formula One tracks to the left of him. So just imagine driving a Formula One car that's got all this horsepower, but there's no drivers to drive. So that's why scaling and making sure that people are there, and it's not just compute, is imperative.
Yeah, I think that's a perfect analogy. I was thinking as you were talking about Formula One, which is close to my heart, is come in for a pit stop and nobody's there to change the tires or check on the engine. A Formula One car and an AI factory are similar in that they're designed to be the maximum force of what it was built for, right? The maximum horsepower, the maximum lap time, the maximum compute. But you need people to maintain it, fix it, design it. And so I think the trades alone are understaffed for the amount of capacity we want to build out or the amount of grid support that needs to be built out. But that all requires people. Um, and then the AI side of it in general, the machine learning side, those jobs are creating themselves as this progresses. And I think I saw the other day an AI ML job posting for people with expertise in that area is up 450% in terms of job openings, and I don't know if there are enough people to even fill those roles. So the backbone of AI compute is still the people that are maintaining it, putting it together, and designing it for the future, certainly.
Yeah, no, that makes perfect sense. And so, you just teed me up, Brandon, into our next question. How does the current skills gap in AI infrastructure manifest, and where are we falling short as an industry?
Well,
Yeah,
I'll take that.
go ahead.
I've talked about it once so many times that we've got these silos and we've got these deep expertise in our silos. So you take electrical, mechanical, structural, networking, architectural. We all do great, but we all do it so well separately. Infrastructure teams understand power, they understand cooling, they understand networks, but they do not understand what the model requirements are. Now, add to the layer of that complexity, you've got data scientists who can build models, but most cannot speak the language of resiliency or latency. Then you start adding security teams to it who know how to protect networks, but they do not know how to protect the training pipelines. The gap shows up as delays, cost overruns, architectural issues, and the lack of ability to scale up. So, it's very, very theoretical. Um, and though it might be practical, it's practical in its own little tiny domain, in its own silo. And we are unable to translate that skill set and that knowledge base over to the other folks and our business units that are in our space. So yeah, the skills gap with the AI growth and the lack of uh, ability to be transparent and transfer knowledge horizontally and vertically to other business units, it's going to be a challenge.
Yeah.
Yeah, and I was going to add, I've heard Nabeel talk about this as well, and I'm a perfect example of this in that from a battery technology perspective, that's where I've spent, my career. That's where ZincFive has operated as a good example. And now the IT side and the infrastructure side are merging. So there's no longer white space and black space, there's gray space. So battery guys need to know what the IT is doing, and IT needs to know what the electrical infrastructure are doing. And that trend that's across the entire data center and all the subsets and verticals that may not have interacted as much as they need to going forward. So, our groups are having to learn about AI compute and how the servers operate. And, for the last 10 years, we didn't care. It was the battery and the electrical infrastructure was in a way separate. So it's about crossing those boundaries and it's about upskilling, right? We talked about people. There are great people out there. Some of them need upskilling. Myself, I need to learn more about IT compute to be effective. And that's going to be a challenge for the industry.
Yeah, earlier here, Brian and I actually have had several conversations. I mean, especially a good example would be the large language models. So what we have started to see is that there is a spike in nature of these large language models. So you actually develop this and deploy this large language model. It goes out, starts capturing all this information, and there's going to be periods that it's just going totally bonkers and, capturing information, mining information, and then inferencing it, right? So
Right.
though you might be designed for X megawatt of compute, you're going to see this spiky nature of the language models. So now it's going to say, okay, I need more energy, more energy, more energy. And that's when systems are going to start crashing. Hence the reason why, you know, we have heard this term before that battery is like the weakest link in the chain, or in the past it could have been the weakest link in the chain, but now it's the most important link in the chain to ensure that you can get through that high variability of compute demand as it's changing throughout the day of computing these large language models. Otherwise, the systems are going to start crashing.
Yeah, that's exactly right. And ZincFive, our technology, as an example, we've been testing it over the last year. It turns out it's a great fit for this application. But to discover this application and to work with it successfully, we have to break down that barrier that Nabeel was talking about in terms of skills gap, right? And crossing through verticals so that the battery infrastructure team, which used to be a liability or just one piece of the puzzle, is now the piece of the puzzle and an asset to effectively driving your AI compute as fast as a Formula One car, right? And chasing those lap times. Um, it's important. So, we have to kind of cross those verticals successfully and upskill everybody and start learning things that we didn't used to have to know in the electrical infrastructure world.
So, what can leaders do today to attract and retain the kind of talent that will shape the next phase of AI-driven infrastructure?
Oh boy, I mean, there's some great examples. I mean, though I'm not necessarily the biggest fan of Elon Musk, but he's done absolutely amazing because he's at heart a technologist. So the lesson that I would take away from that is to create an environment where technical people can actually do meaningful work. You've got to give them clear ownership, room to experiment, make mistakes, and the chance to work across multiple disciplines. And to be honest, about the mission, the best engineers want to solve hard problems, not just tune into dashboards.
Yeah, I'll second that in saying my team's heard me say it a lot, but extreme ownership and challenging people to accomplish what's in front of them. And that could be something they've never done before. That could be new skills they need to acquire. But as long as people are coachable, trainable, willing to learn, willing to adapt, they're going to be successful in tomorrow's market. So, you know, for what leaders can do, we need to attract talent that is trainable and coachable because I think the changes that happen over this year and over the next 5 years are going to be an order of magnitude larger than the changes that have happened in the last decade. And so strong teams today are going to be teams that can be completely different next year and can leverage new tools and leverage new technology to increase output um, without much issue. So, find those people. They may not know everything today, um, but if they're trainable and coachable, I think they're the right talent for tomorrow.
That sounds great. Thank you so much. You have been listening to Why AI Still Needs People Today, and thank you so much for your time. Greetings. My name is Alyssa Miller. I am the CEO of iMiller Public Relations, and I am proud to host this discussion with Nabeel Mahmood, who is a strategic advisor for ZincFive, and Brandon Smith, who is the Vice President of Global Sales and Product for ZincFive. So let's get right into it, fellas. People, power, and the future of AI infrastructure. That's what we're going to talk about. As data centers consume more energy, How can the AI and energy sectors better collaborate rather than compete for resources? Nabeel, you want to
So,
jump into it?
sure. So it starts with being transparent. Energy providers need early visibility into demand curves. The artificial intelligence operators and data center operators need a realistic picture of what the grid is capable of doing and what the potential grid constraints might be. And when these conversations start happening upstreams, we can actually co-design solutions instead of scrambling after the fact, like we have actually started to see in the past year or two. Um, Co-location with renewable projects, flexible, load agreements and power agreements and shared investment models can actually potentially also turn a competitive environment of electrons into a partnership. So, I mean, my whole message really is that we are now at the fingertips of every user and consumer out there. We are the necessarily evil. As a matter of fact, you can't run GDP or a company without data itself. So, being that critical and a national asset for any country out there, we need to actually be very, very transparent across all the domains where data touches, including the energy providers.
Super interesting. So, what innovations in energy storage or distribution are most likely to transform the scalability of AI infrastructure, Brandon?
Yeah, that's a great question. It's an important one. As Nabeel mentioned, it's about turning electrons into a partnership, right? So the utilities are constrained, the data centers are constrained, and so if there's not a solution somewhere in between there, then there's no path forward. I mean, grid connects to just get a permit, I think, are 5 to 7 years out at the moment. We have gigawatts in the backlog of data centers to be built. And that's gigawatts of true demand. And if we talk about the AI dynamic workloads and the way synchronous AI computing creates these electrical spices or these spikes or these pulses, then that 100 megawatts or gigawatt or 10 gigawatt is a fraction of what's actually being delivered to compute because you have to allow for these electrical spikes. And so the advancements are in the energy storage sector, advanced battery technology and other infrastructure like what ZincFive makes are the key to unlocking the AI compute, unlocking maximum capacity of that factory or that colo, and then allowing the grid to actually supply usable power and energy to these data centers. Because you can lean on these, ultra high power, ultra fast discharging technologies like nickel zinc to mitigate these spikes and these pulses. So the battery takes out that kind of unnecessary demand. It can relieve the grid, it can relieve the colo from not having to over design, overbuild, or over ask for power. So when we talk about AI factories and data centers and how much electricity they consume, and that's going to go up, and then you add in these kind of complications with AI computing, it really is looking like advanced storage, advanced battery technology solutions like what ZincFive offers is going to be the key for both parties, the grid and the customer, to unlock that compute.
And so, how do we reconcile the tension between the rapid expansion of AI and the limits of our current grid systems then?
Earlier conversations, I think the grid is constrained. We know that. The data centers are hungry. They want to build, they want to grow because the demand for AI is through the roof. And so earlier planning, earlier technology conversations, looking at new products in the marketplace. What was once just a battery and one small piece of this data center puzzle and not one that was looked on favorably, is now the key piece to unlocking AI compute and running that at maximum capacity. So it's just a change of thinking. It's a change of structure. How soon are we talking to technology vendors? How openly are we communicating market problems to technology vendors like ZincFive who can solve them? Um, and are we talking with the grid? And are we all talking with enough time to kind of solve these problems? Because there are solutions.
Yeah, no, I totally get that. So, Nabil, I'm going to throw you this question. Are there any partnerships or cross-sector models that show promise for aligning human, technological, and energy infrastructure growth?
Well, so where we started being transparent, I think that's the base of the model, right? But let's expand on that. The most effective model will be the one where utilities, data center operators, hyperscalers, the government sit on the same table and they sit early and treat the project like a shared ecosystem instead of three separate agendas. When we can start co-planning, we will end up with the sites that fit communities, work with real grid constraints, and still keep pace with the compute demand. And what's interesting is how these partnerships will naturally pull in schools, universities, labs, and once a region knows a major data center and or AI factory is coming, they will start building the talent pipeline around it. Now, we'll get training programs tied to real jobs, research centers that will plug into industry problems, and internships, apprenticeship pathways for people who would have never pictured themselves into the mission critical and the data infrastructure field. There will also be new class of partnerships, which I've started to see form between energy developers, data centers, and AI operators. They're building campuses anchored by dedicated generation and storage and inviting local and regional stakeholders to help these uh, with permitting to help develop the workforce talent. At the end of the day, it's going to create alignment around the growth of the economy, the technical and the social impact, not just a race to build the biggest and the baddest data center facility.
Yeah. So is there anything we can do to ensure that power and people evolve in sync to meet AI's accelerating demands?
Sure, yeah. I mean, we already know how to plan power. I mean, we have done this for centuries. I hope so. We forecast load years ahead, and we've got enough data now, based on this hockey stick that we've seen over the last few years. We can map capacity and we can adjust our investment decisions based on what the future potentially might look like, based on the data that we have actually captured, particularly in the last 3 to 5 years. And we need to apply that same discipline to people as well. So too often companies build aggressive AI roadmaps, and I've started to see quite a bit of that recently. And then they later realize they don't have the skills to support them. The smarter approach is to treat talent as part of the core infrastructure, not an afterthought. And that means projecting the skills that we will need in 3 to 5 years, identifying where we have got the shortcomings today, and partnering with universities, trade programs, and industry groups to build that capability. It also means creating environments where people can grow within the technology sector. If workers only learn the tools of today, they won't be ready for the systems of tomorrow. So the goal isn't just about hiring and robbing Paul to pay Peter, it's building a culture that develops the talent we need and keeps them excited about the future of our sector.
Yeah. Anything to add, Brandon?
People, right? People are the most important asset, even with AI coming in and being able to do more with less, or do more with more is also the opportunity here. And it's just people, finding good people that are trainable, coachable, and teaching them and making sure we have the expertise across the network to continue to build, develop, and then ultimately service and support this infrastructure for centuries, right?
Yeah, you got it. Thank you, folks. You've been listening to People, Power, and the Future of AI Infrastructure with Nabeel Mahmood and Brandon Smith of ZincFive. Thank you for joining us. Greetings. This is Alyssa Miller, CEO of iMiller Public Relations, and I am honored to be in conversation with Nabeel Mahmood, Strategic Advisor to ZincFive, and Brandon Smith, Vice President of Global Sales and Product for ZincFive. Today, we're talking about real talk about what's next. You can see if you can see my screen, I'm putting air quotes in sustainability. It's become a buzzword. What does true circularity look like in the context of AI infrastructure is really the topic of exploration here. So, what are the uncomfortable truths in the industry when it comes to sustainability and AI growth?
Yeah, I'll kick us off there. I think the uncomfortable truth about sustainability is that it's here to stay. Um, I think sustainability in the US markets tends to weave in and out of policy based on who's in office and whether it's critical to policy that's in front of us or not. And I don't think that the companies that are looking 20, 30, 50 years in the future, I don't think they have the luxury of forgetting about sustainability for any period of time. And I think you can see it in the EU markets and the APAC markets when we travel and talk with customers and markets. Sustainability is integral into what they do, and it doesn't kind of flex with the time. They know that the decisions that we make today, the technologies that we push forward, and how we kind of operate are going to play 5, 10, 15 years in the future. And that's where sustainability, needs to be a key part of everything we do. And as AI scales and the growth that we're looking at and the technology inflection curve and how fast technology is changing is going to mean that equipment refreshes are faster, whether it's servers, whether it's electrical infrastructure, refreshes are going to happen faster. So that means your emissions are going to go up as you consume more product. Hopefully, the product you're using is recyclable. That's where technology vendors like ZincFive come in with recyclable battery products today. Sustainability is not a wavering initiative for us. So it's a buzzword, and it's I know people kind of talk about it in and out of consciousness, and but it's here to stay, and it has to be part of everything we do. And you know, as we build and as we design AI factories and co-locations moving forward, we have to be building and purchasing with sustainability in mind because it's here to stay.
Amazing.
Yeah, I'll just add to it that, I mean, one uncomfortable truth, like Brandon said, is that efficiency is not a silver bullet. And another truth is that many companies have used and continue to use sustainability as a branding exercise rather than a serious operational priority. And it's easy to talk about carbon credits or green purchasing, but much harder to redesign a facility, rethink procurement, or challenge the assumption that every workload needs to run at full speed at the time everywhere. The biggest truth is that our appetite for compute may eventually outpace, well, I believe it is already outpacing what the grid can deliver if we keep building the way we have been building. And that's a difficult conversation because nobody wants to slow innovation. But ignoring the constraint doesn't mean that we're going to remove it. We have to be honest about the trade-offs. The more artificial intelligence we build, the more data centers, the data sets that we build, the more we need to rethink about upstream energy planning, hardware life cycles, and even the design of the models themselves. So it's an uncomfortable truth that efficiency is not the silver bullet.
Yeah, I get that. Are there any realistic pathways to circular data centers, or is this still an aspirational concept?
I
I
would say
think
we are not there yet, but we're definitely moving that direction. A lot of the building blocks already exist. Modular hardware has started to improve, and some operators are doing great work on refurbishing, redeploying components, increasing the life cycle of the equipment. I mean, heat reuse, for instance, has started to gain some momentum, especially in colder regions around the world. More data centers are partnering directly with renewable developers and building on-site microgrids as well. The true circularity is still sort of aspirational, in my opinion. The challenge is less about technology and more about alignment. Operators want reliability. I mean, we can't actually have a downtime, but then, cost efficiency and that those factors come into play as well. And then, of course, community wants jobs with environmental stress, getting all of that lineup takes planning and being transparent across every single domain within this mission critical environment that we are in now.
Yeah, and I was going to say the exact thing, same thing. Circular economy is aspirational, but I think it's possible. And it kind of goes back to what I was saying about sustainability being a key focus all the time, is if we're not designing with circularity and reuse and recycling in mind today, it's going to be difficult 24 months down the road, or 5 years down the road, or 10 years down the road, depending on the product's life cycle. So even from a long life technology perspective, like nickel zinc batteries and UPSs, those are 20-year products. So we're not talking about very quick refreshes, but we know in 20 years, we need to be able to recycle and reuse those. So integrating a technology that's recyclable today, relieves you of that pressure 10 years down the road. And 10 years down the road is probably when a circular data center and fully recycling and reusing everything is probably a little bit more in line with what's actually happening than today.
Yeah,
Yeah.
I'll just add to what Brandon said is I think the most important thing is that we need that commitment and a consistent design choice. Brandon talked about the life cycle of the asset itself, so longer investment windows. And the most important thing is the leadership willing to think beyond the next quarter. That's the most important thing.
Right. So how can policy, technology, and business incentives align to make circularity more than a talking point?
Well,
You
I kind
want
of mentioned it a little bit. I think, I won't speak directly on policy because that's not my expertise, but I can tell you based on the markets that I interact with, the US definitely tends to embrace and release sustainability every 4 years or 8 years, depending on the geopolitical cycle. And other parts of the world, it's just built into everything they do. So to some degree, the companies in the US that are 20, 30, 40, 50-year planners that want to be here forever, we have to just keep sustainability at the forefront. And it's a value proposition in nickel-zinc and in ZincFive's company. So, the policy, the regulation, all of that can certainly help. And but for us, it's just in what we do.
Excellent.
Yeah, when policymakers are going to start signaling what their values are, industry is going to start paying attention. The real alignment, I believe, is going to happen when all three, that is the policy, technology, and business interest, they align and they move in the same direction. That's when circularity is going to become more than just a talking point. It's going to become a standard that we can build and grow upon.
Amazing. Thank you so much. You have been listening to Real Talk about what's next, more than just buzzwords. Hello, this is Alyssa Miller. I'm the CEO of iMiller Public Relations, and I'm thrilled to be in this conversation with Nabeel Mahmood, who is a strategic advisor to ZincFive, and Brandon Smith, who is the Vice President of Global Sales and Product for ZincFive. In our topic today, we are looking beyond AI. So we'll start with you, Nabeel. What emerging technologies, AGI, BCI, and off-the-grid systems do you believe will most disrupt how we think about infrastructure?
Well, so when people talk about disruption and being a futurist, that usually jumps straight into artificial general intelligence or brain-computer interfaces, like you mentioned earlier, because they sound extremely futuristic and they will absolutely reshape the landscape over time. But if you're talking about the near term and the practical disruption, the kind that forces us to rethink infrastructure in the next 3 to 5 years, the biggest shift is going to come from the off-grid compute. Now, being able to build self-contained campuses that generate, stores, uh, inferences, and manages its own power removes one of the biggest barriers that we have today, dependencies such as on the traditional grid. The grid wasn't designed for artificial intelligence. It wasn't built for ultra-dense loads or rapid scaling. I believe that off-grid systems are going to give operators the flexibility to put the compute where it makes a lot of sense, not where the grid happens to have capacity. And we need to get closer to the user. We talk about edge and other technology platforms where bandwidth and latency become critical. So the off-grid is where the future is. Now, artificial general intelligence and brain-computer interfaces will continue to push the infrastructure requirement even further. And like I talked about, latency and bandwidth and real-time processing. I believe there's going to be this bridge between today's limits and tomorrow's demands. They let us experiment with near power architecture. It's going to test higher densities and design sites around performance instead of constraints. So, for instance, I mean, we just recently heard the announcement of 1.5 megawatt per rack. I think Brandon and I, when we started our career, 1.5 megawatt was a data center. So while these technologies such as AGI and BCI will eventually transform the way we build, I believe that off-grid compute alters that equation for now. And it's immediate, it's tangible, and it forces us to rethink the relationship between energy and compute at a fundamental level.
Pretty cool. So, what role does energy innovation like ZincFive's work play in enabling a more resilient and decentralized future, Brandon?
Yeah, it ties into a lot of what Nabeel was saying here, where if we have compute that's off grid, there's a lot of benefits there. And ZincFive's product catalog is high power, short duration battery technology solutions. So that's anything that's off grid, on grid, but that's using electrochemistry to bridge that gap between a long duration off grid solution like natural gas generators or so on, or bridging to from the grid to a normal generator setup. So innovation in the energy infrastructure, both with battery technology and with long duration assets like hydrogen fuel cells and otherwise, are going to allow data centers to build more flexibly, potentially completely off grid. And that's really going to allow, I think, the AI compute to be developed at the scale that we kind of all hope. With grid interconnects being 5 to 7 years delayed, I don't know how we build hundreds of gigawatts without leveraging the infrastructure innovation from companies like ZincFive and others that are trying to solve that.
Yeah, that makes a lot of sense. All right, so I'm going to ask you guys to grab your crystal balls. If you could make one bold prediction about the convergence of AI, energy, and human capability over the next decade, what would it be? We'll start with you, Nabil.
Oh boy. So I guess I'm known for my silver, what is the magic 8 ball, right? Uh, my bold prediction is that we are going to see the emergence of what I call intelligent infrastructure. We are going to move past the idea of infrastructure as passive equipment and into a world where the data center, the grid, and even the workforce operate as an adaptive system. This conversion was going to blur the lines between human decisions and machine guidance. Humans will start to lead, but they will be supported by systems that understand the environment, the constraints, and the opportunities more quickly than any person can. And it becomes a collaboration between the capability, compute, and energy. If you look back in 10 years, I think we will say the biggest shift was in artificial general intelligence, brain-computer interfaces, space exploration, or even the models themselves that we're building today. It was the moment that infrastructure started to think with us. And
Mm.
that shift will define the next decade of innovation. Now, granted, I am of the firm belief that there's no substitute of human intelligence. So humans, as long as we have a good layer of understanding and education, we will always define the compute and the quality of life for the humankind.
Amazing. All right, Brandon, you had a moment longer to think about your prediction. Got your crystal ball or your crazy 8 ball. You're
Yeah,
up.
yeah, yeah. I'm going to go a slightly different direction. I think AI will, so I believe AI is the mental multiplier. So the birth of the engine was the physical multiplier, right? If you want to lift up a boulder by hand, it's very difficult. Now you have a tractor or a crane, it's very easy. So we can build skyscrapers in record time. AI is the mental multiplier. So if you want to think through or develop something, well, albeit medicine or new infrastructure, architectures, new technology, new chemistries, AI is going to be that compounder. It's going to help very intelligent people do more in one sitting. So with that, I also have this bold prediction that AI is necessary for the future of human capability. If you look at civilizations across the world, most of them are below the replacement rate, meaning that they average fewer than 2 kids per couple, which means that the populations have a chance to decrease. And if they decrease at a rapid pace, they're very difficult to recover. So, and then you look at countries that have an upside down pyramid, right? Where there is an aging population and not enough young people coming into the workforce to sustain that. You couple that with being below the replacement rate, you have significant issues for a first world economy. And so you need AI, you need this infrastructure to give the human capital that is here the ability to do more with less, right? That mental multiplier. So I think there's a theme that AI is coming for everyone's jobs. And I know we tend to play on the infrastructure side of building that out, but I believe that AI is here to compound everyone's output, and it may be just the thing we need if, population reduction is truly in the future for the next 10 or 20 years.
There you go, folks. You've heard it here. A couple of predictions about convergence of AI energy and human capability with Nabeel Mahmood and Brandon Smith of ZincFive. Looking beyond AI. Thank you so much for tuning in today.